Alright. So I think the stream has started here. Now my previous one, I was cramming for a test, I think. This one, I have been spending the past 4 hours kind of just fighting an operating system and learning Linux command line. That's what I've been doing the past 4 hours. That's why it's 5:52. I'm gonna get my hour in, maybe 2 hours. But that's gonna be it today. I think today, it's not gonna be too much. Tomorrow morning I will, probably gonna do a lot, but yeah, oh, we don't need the intermediate algebra. I think I know this. I think I know all of this, actually. I'm gonna go, like, midway through and see, like, I just... What is this? Okay, we're adding fractions.
You get it wrong, or you get different things already, it does something wrong, go back and fix that mistake. You just multiply by the wrong thing. That's okay, go back and fix it.
As 2K views. So most people aren't going for intermediate algebra. That's good for me. I did find out today that I have to take a test. It was a placement test for my college. And it's like before an orientation thing. And there's 2 of them. One of them, if you're an international student or like anyone who has an ACC math score over 24 submitted, then you have to take one that's called D test, and another is called B. I got assigned B because I didn't turn my ACT. I didn't have a 24 math. I had like a 22 or 23 math because I did not study for the math on the ACT, and I got a 22. So that kind of tells you how much, like, how behind I am. So I'm gonna try to catch up here, and I have to take the easier one, which is just I guess just what is it called? Placement tests. I think it's called B, and there's a little section here. Okay. Let's go here. Yeah. And the thing is, though, yeah, all engineering has to take this by May 22nd. Right now it's March. So basically, the remaining time in March and then April is just going to be purely dedicated to math. That is all I'm going to do. Just building some fundamentals. Okay, here's a B test, D test. Oh, 25 actually. Okay, 24 and lower. Yeah, mine was not even close, actually. To be fair, I forget most of the geometry stuff that I learned, right? So, cut me some slack here. He doesn't have a geometry one. There's trig and pre-calc, and then there's calculus, obviously. I did calculus yesterday. It was the limits. I actually took that test today. I was cramming for yesterday. I was cramming for like 3 hours. I finished that last part that I forgot to yesterday, and I got probably like a 80 on that test. I didn't study the limits of the graph. The limits. I didn't understand that concept at all. And if I wanted to, I had to watch like a whole another hour of video understanding that. And I would have got like 20% more, so it wasn't worth it, you know. I had to, cut my losses there. Or could have stayed up, but that obviously is not realistic. Long term, it's not sustainable. So, pre-calculus, I've had to jump through a bunch of this. I actually have notes of when I started this one. It was, was it logs? It was not logs. It was long division of polynomials. So I think today I'm gonna review a few units of pre-calc that I've already done. I'm just going to be reviewing, and tomorrow I'm going to do a super review type of day. I'm just going to review everything that I learned from this course, and then kind of continue, just so I don't, so I just start to cover all the bases. Intro functions. Now domain of functions. I mean, I'm pretty good on that. Now inequalities and drawing and stuff, I probably not. I'm gonna do some review over that. So, and what took 4 hours was me trying to set up a webcam, and I did multiple times, but I don't know. Ubuntu was just not. It was not having it. Okay, it wasn't having it. In fact, can I quit this? Okay, good. I can quit both these. Good. All right. So I think, yeah, we're gonna start a little bit fresh. I'm not gonna go through the entire video. I'm just gonna put it at 1.5 speed, maybe 2 times speed. Yeah. So I think I'm just gonna probably.
Hi, welcome to another video.
This, how to develop. Okay, it's just this. Okay. Plugging in stuff. And then negatives. It's in the parentheses, outside parentheses, blah blah blah. Just with the variable. Quadratics. Maybe actually. Completing the square. Proving the quadratic formula. Multiplicity. Yeah. Yeah, so I think I'm gonna. What I'm gonna do is just go on the first video, okay?
Welcome to the start of.
That's what I'm gonna do. Well, actually, okay, maybe not this. This one's way too. No.
Hi, welcome to.
I actually don't know where to start, so. Okay, just understanding square roots and stuff. You fold out x plus h squared. Oh, he did the difference quotient. This early, really? This early? What? What? Yeah, I was just doing this yesterday. Okay. Fold x plus h squared. Actually, this is exactly what I was doing today. So. I'm pretty good on this actually. I just did this today.
Hi, welcome to another video. In this video, we're going to discuss.
I think we're going to start with domain. Yeah, domain. Vertical line test. I mean, that's just like a little special area as part of the curriculum, but whatever. But our main thing here is that I need to start out Calc 1 first semester. And because I'm not starting at main campus, I don't have all the credentials to be in main campus, which I need to make up through here in a regional campus so I can transfer to main campus, blah blah blah. All that whole hullabaloo aside, I guess just seeing the study materials, they put a sample here. And it's like this. So this is Algebra 2 right here. Expressed in simplified form with no negative exponents, which is, I don't think I've ever done this in my life. I'm not even gonna lie, I've never seen that before. Write the equation of the line containing the point 1, 2 and parallel to the line 2x plus 4y equals 1. I also remember doing this, I forget everything about it. So I'm not sure exactly what to study here. I mean, this looks like the questions I was getting on the ACT, and no wonder I got a 22 because these questions I do not remember any of them because I learned them all in Algebra 1, and they're kind of just irrelevant. Like I guess half of it is like irrelevant. Now this geometry here, I could do it. Like if you asked me, like I don't know, 3 years ago to do these questions, I would have easily done them. It's just I haven't done any type of geometry in forever. Like if I want to try them actually. The two triangles pictured below are similar if the perimeter of the second is 19.5 give the lengths of its three sides. Perimeter of the second. Okay, so then you would add the first and then the second and then divide the first perimeter with the second, get the ratio, and then ratio out 3 of that, 1 of that, and then 2.5 to that. Okay, yeah. Rectangular paste posters, 3 times eyes is wide. I hate word questions. I don't care how easy it is. I don't care how hard it is. It's just... No, I don't like it. How many gallows of 40% alcohol solution must be mixed with 70% solution to obtain 30 gallons of 52% alcohol solution? Is that stoichiometry? That is not stoichiometry. I sound dumb. I know it's like chemistry. It is not chemistry. It's just percent formulas and stuff. So this is the real stuff here. Well, actually, not really. Okay, maybe the end is. Hold up. Here we go. Yes. What am I looking at? Okay. We're seeing a parabola. A -1 is kind of obtuse. Not obtuse like oblique. I don't know. The angle A is 45. I haven't done this in forever. So, obviously, I'll have to study a lot of this. Now, the B test is logs, exponentials, polynomials factoring, linear equations, exponents, prompters numbers, number line, arithmetic of sign numbers, scientific notation. Yeah, I got a lot of holes there. D-test, not so much probably. Trig functions, evaluate trig functions. I'm pretty good on trig functions. Not the best, but not the worst. These ones, no. These ones, no, we haven't even got there, I think. This, halfway. Inequalities, quadratic equations. I'm like, okay. This one, this one I'm good on, yeah. Quadratic, I'm good on actually, yeah. Exponential logs, not so good. Right angle, no. General trig, okay. Okay. Yeah, because I don't want to take college algebra, trig, or pre-calculus. You know, first semester, because it's just gonna prolong everything, and you don't want that. So, that was a bit long-winded, but yeah, I think I spent. Oh my god, I spent 20 minutes just talking. Alright, I'm gonna work. I'm gonna mute my mic. Do this.
That's domain and how to find it for functions that are defined over real numbers. So let's get right to it. The last video, we sort of explored domain a little bit. I gave you a definition for it. We looked at what we can have for inputs that give us a real numbered output. Now, right now, when we say that, a real numbered output, we can have functions that have outputs that are imaginary numbers or complex numbers defined over the complex. But for things that we normally graph, we're going to restrict this to functions that are defined over real numbers. And that gives us a pretty clear definition of what domain means. So let's check it out. What the domain is for us is the set of inputs of a function, so these numbers that I can plug in, that give us a real number output, something that's not imaginary and something that is defined, so not the function divided by 0, and that the function can handle. And that's later in the class we talk about some functions that can't handle like negative numbers. So we're going to discuss that today. We're going to look for the two main problem areas that we're going to focus on, and then there's a third one that we get down the road. So when we talk about domain, you got to keep that in your head. So the set of inputs that gives a defined real number output for a function. There's two problem areas that we really look at. Now down the road, when we start talking about logarithms, and we're not quite there yet, we'll get there in a little while. Logarithms are going to add one more sort of problem area that we have to consider. It's not really a problem. It's just something that we have to consider that, hey, there's some numbers that I am not able to plug into logarithms. There's also some numbers that I can't plug into square roots, or in general, even roots or denominators. So when we think about square roots and denominators, something in our head's got to be we might have some issues with these things. So let's explore those today. We'll look at a few examples on how to find domain, what to be thinking about, and what not to get confused on. So again, one more time, we got this thing called domain. It's a set of inputs that gives a real number output for a function. And for now, there's two areas that we will look for. Later on, we'll add logarithms to this. But for right now, we're going to really be concerned about square roots, and we're going to be concerned about denominators or fractions. So in square roots, if you remember this, when you have a square root, it can be 0. That's what we explored in the last video when we evaluated and said, hey, can you plug in some number that gives you 0 inside a square root? Yes, that's fine. Can you plug in some number that creates the inside negative? The answer is no. So when we see a square root, in our head, we think the inside has to be positive. It's a really optimistic function. It's all going to be positive. What that means is if we plug in numbers that make the inside, the radicand of our square root, that make that negative, those are problem numbers. So what I always like to tell students is that a square root.
Okay. I want to do one session to this, so I think I'm going to plan out my stuff here. Instead, we're changing it midway through. I know that's like a bad thing. It's like a little no you shouldn't do. I'm going to open my notepad here. That is webcam commands. Let's see if I can get out of this file. New tab. Yeah, get out of here. No, discard. Alright. Cool. So, what is it? Today's Friday, yeah. Let's just look at the days of the week, right? It's the best way you can do it. Make it all rigid and stuff. So, oh yeah. Okay. So, I think on Mondays, or even just these 5 days of the week and midweek, I am going to do. Hey, what are we even studying, right? So I think we should probably study math. There's also different resources here. So what is it? Like Professor Dave Explains. Like this. He also has stuff. And mathematics right here.
I'm Professor Dave, and I want to teach you about mathematics.
Okay. I think there has to be some like geometry like course, right? I guess not. Yeah, I guess not.
I'm Professor Dave, and I want to teach you about.
I want to teach you. Okay, obviously I'm not doing that yet. That's for later. Ah, here we are. Yes. So, I'm gonna do these videos here. Right here, Professor Dave Explains, mathematics. Let's see, it's my library. I'm gonna go here, say this is my library. I'm gonna go to my channel and go to my library. I'm gonna see organic chemistry tutor, maybe? Organic chemistry tutor? Hey, intro to geometry, yes.
In this lesson, I'm going to go over some basic concepts in geometry that you want to be familiar with. So the first thing we're going to talk about is a line. What is a line?
Okay, this might be a little too basic, alright.
This video is a basic
This one might be more relevant.
geometry review. Is pi r squared. So for this,
Okay, here we go. Okay, this is a good video. We're gonna save this. So, what? I'll make a new one. Geometry. Got it. Blah blah blah. Yep. What's this?
in this video, we're going to focus on finding the area of different shapes that you'll encounter in a typical geometry course.
Okay, there's no way he doesn't have a playlist. Come on. Like, by this point, come on, there's no way. Please. No way. Okay, here we go. 142 videos. Jeez. Oh my. Oh my lord. Some of these are 50 minutes. Oh, these are math preps.
In this video, we're going to focus on solving common ACT math questions.
Ah, here
Now,
we
for
go.
each
Now this should, it's not the ACT, but this should be similar to the placement test. So, I think we're going to watch these instead. They're also like lecture style videos, and it's just practice problems. They kind of just let you dive in. They don't do like, it doesn't do the introduction, explain the concepts, blah blah. You probably know the concepts, and you just gotta see the problem. You're like, oh, okay, it's that, blah blah. This video is also not membership locked, so. Yeah. Alright, I'm gonna save these then. We'll save the playlist. Alright, good. Alright. I gotta keep doing stuff for 50 minutes, okay. I feel like this planner is not very good here. I don't know. The main thing here is just to study every single day until I become an engineer. And that's the premise. It's nothing special. It's just studying every single day, no matter the time, at least 1 hour per day, one session per day at least, at the minimum per day. And I should be able to do it every single day. If I don't, it was probably because I died. I'm gonna section out into different blocks and stuff. I don't know if I should like study about studying. It's a meta studying. I don't know. Oh yeah, this would help, right? Yeah. Yeah, that would. Not very sure what to do here. I guess I could ramble more. So I'm gonna just study this for this month here, so this week right here, and then this week right here. Not too much, and then there's gonna be a little break here. This whole week is gonna be like heavy duty studying. These weeks here is just math. This is all just math. All just math refresher and filling some holes. Here is where I take tests and all that. June and July is calculus. It's just gonna be calculus. It's all it's gonna be. It's just purely calculus with some other things on the side. Of course, there's gonna be some like electronic stuff. And by that point I'll have to have a webcam to even show what I'm doing, and there can't be a screen either. So, yeah, each stream should be 1 hour long. The maximum I'll do in one day is 10 hours of studying, which is 12 hours if you include the breaks. So it's gonna be 12 hours spent of studying. That's gonna be the max we're gonna do. I'd probably have to get up at like 4 a.m. for that, so I can get there, MIC at 5, and then end it at 5. Obviously, that's not gonna be every day. Definitely not. But I have to do my first year chef. I have to do all that stuff. I had to. So this year is just gonna be. I'm just gonna be in the dark, and I'm just gonna just do math, and that's it. Just pure math, and that is it. It's just pure math. That's all I have to worry about right now. It's just pure math. Physics, of course, physics, and some like introductory engineering, and I'm gonna do some programming as well. C++, C++ and Python. I'm gonna do that. Python's more high level programming in the abstraction levels. C++ is like, is it high? I swear it's not high. It's low abstractually, in the abstraction level. It's like, because level programming doesn't fucking mean, it's such a hard language, right? Oh, it's so hard. No, then assembly would be like God, right? Or maybe it's just C. Am I thinking about? Requiring high performance. Say high level. What the fuck does high level mean? Oh my. Okay, it's C hash, right? It's just C hash, or is it C? Oh my lord. Okay, answer my question, please. The high level. Oh my god. Object-oriented functional paradigms. All right. Yeah? They're all high level. What is a low level programming language? What is a low level programming? Like what? Okay. Alright. I never knew that. Ever. There's a Coursera for it. Oh, it's just okay. Alright.
My software engineer makes $133,000.
Yeah. Boot camps. Certificate. I mean, it's Coursera. Why wouldn't they say that? That was probably like half their business revenue in 2020, I bet. In 2021. Yeah, I'm gonna do some C. Programming wise, lots of math mostly. Some C. I'm gonna do some stuff with semiconductors, electronics, especially when we get my webcam up and working, which is gonna be very soon. Very soon, meaning like 2 to 3 weeks, right? And I don't have anything to study here. I think on day 3, I'm gonna study for. I actually don't know. I'm gonna say like 4 hours tomorrow. 4 hours of studying, like 6 to 10 a.m. You know, nothing too crazy. It's just gonna be some math. Make sure my playlists are up. Okay. Good. As I said, it has to be at least 1 hour every single day, so I have to keep streaming, even though there's nothing to stream. How long am I gonna expect to do this consistently? Is also a very big question to ask. Day 2 into this, because it's every day until I become an engineer. What I mean by engineer is I mean you get an ABET certified degree, and what I have subjecting myself to in undergrad is electrical engineering, or electrical and computer engineering, but it's basically just electrical engineering with some computer engineering here and there. So yeah, and what is it called? What is it? ABET certified or something? It's something like that. I don't get into history, but I don't care. But how many days are in 4 years? Oh, okay, let's say 5. Say 5. It's probably like average. That is 1,826 days. I repeat, 1,826 days. I am 2 out of 1,826 days in, which is 0.0011 rounding up percent of the way there. Just to kind of put it into perspective. So, and of course, if I'm going to be doing an engineering degree, especially the first 2 years, I'm just going to be kind of studying a lot every day. Even on Christmas, yes. Even on like Christmas, even on any day, I will put the ass into the seat, like today, no matter how inconvenient or chaotic it is. But it's not gonna be chaotic. Right now it's chaotic because I just not much went to plan, but it will from now on. I guess electronic engineering is probably one. Semiconductor device modeling, device fabs, chip design. I like chip design. It's a cool phrase. Let's see here, signal processing, pretty cool, but not my forte. Computer engineering, obviously. Photonics and optics, not much. On like spectroscopy and all that. Mechatronics, not really. Yeah, professional certification. Okay. Software engineering, AI, operating systems, microcontrollers, Arduinos and Raspberry Pis and stuff. I'm just not it today. Well, not right now. Early today, maybe, but I did study like the entire day today. Too bad I didn't show it, so it doesn't count. But these are a lot of words I just don't get, and hopefully I'll get them. I can go back to this and try to parse this out, right? Case Western, really? Case Western's a pretty good, oh yeah, I bet. There we go. Accreditation Board for Engineering and Technology Incorporated is non-governmental accreditation organization for post-secondary programs in engineering technology, computing, and applied natural sciences. As of October 2023, ABET had accredited 4,674 programs across 920 organizations, 42 countries. ABET also accredits online educational programs. It accredits 4,700 programs, 4,700 programs across 920 organizations in 42 countries. Let's see here. Criteria. There's members. There's EC. Blah blah blah. What subcategories here? Okay, BLS, compilers, computer architecture maybe? Not really, no, not really. Robotics, robotics is, not really, no. Computer vision and, okay. Now, this is where we get to, the exciting stuff, is embedded systems. An embedded system is a specialized computer system, a combination of computer processor, computer memory, input-output peripheral devices that has a dedicated function within larger mechanical electronic systems. It is embedded as part of a complete device, often including electrical electronic hardware and mechanical parts. Because an embedded system typically controls physical operations of the machine that it is embedded within, and often has real-time computing constraints. Embedded systems control many devices in common use. In 2009, it was estimated that 98% of all microprocessors manufactured were used in embedded systems. It has memory, power supply, and external interfaces. What is this actually? It's upside down, I can't read it. It's TI, I can read the logo. Texas Instruments, maybe it's a calculator? I guess so. I'm curious what, these are diodes, right? Yeah, those are diodes. I'm pretty sure those are diodes. Like, soldered down diodes. You know, I know a bit about soldering. It's a, what do you call it? They don't call it breadboard. It's not a breadboard. Econ systems, computer modules. I'm curious. What is actually in this? You know, USB peripherals, media cards, tools, stuff like that. I'm guessing an actual job. You're gonna have someone to answer to that doesn't understand any of this and needs it by a specific date. you have to pick a budget, you need to go through like a bunch of hurdles, and most of it isn't this. It's probably just mostly like Excel or something. At least in the actual job. Microkernels and exokernels. Monolithic kernels. Wait, this is Linux and stuff. Yeah, OSs. Yeah. The relatively large kernel with sophisticated abilities to suit an embedded environment. They put Linux before Windows. Okay. All right. Yeah, this is usually what I want to get into. You have to know a bunch of advanced math like linear algebra, differential equations, programming languages, proficiency in those programming languages, years of experience with those programming languages. What does years of experience with a programming language even mean in the first place, right? So, I'm going to go ahead and make a GitHub account. Why not? You probably don't want to do this, right? Live streaming? No, you probably don't. And the homepage is laggy. Yeah, I don't want to do that. No, I'd probably just like leave my whole entire life just doing this. Flops. Yep. No T-flops? No. Teraflops? I guess. Flops, teraflops is just a unit. Right? Yeah, it is. Okay. Oh, benchmarking. I forgot about this. Oh, I just said benchmarking. I was like, oh, what? Yeah, I'm familiar with benchmarking. That's why I have flops in there. You can benchmark IPS. That's not very common. Flops is good. Performance per watt is also common, I see, in the practical world. Input latency, stuff like that. Okay. Cool. Embedded database, embedded democracy, embedded system, processor design. MOSFETs. Has transistors. That's very good. Embedded system text user interface using micro VGA. How old is this? When was this last edited? This is like last year. And there's not much to edit. Silicon compiler. Oh, shoot. Raise level into sign abstraction. The concept of the silicon compiler was first formally described in 1979 by David L. Johansen and his PhD thesis in Caltech. Work led to founding the Silicon Compilers Incorporated. The Ethernet data link controller chip in 1982, the project went from specification to tape out in just 5 months of significant acceleration of the design cycle at the time. Shortly after 834, the SCI team designed the data path chip for the DEC Microvax. The data path for the Microvax. $37,000. You have like trillions, right? An iPhone. 3 years to die manually. Is this even relevant? I don't know. Oh shit. Artificial and machine learning decrease the events closely. These techniques are used to automate and optimize. Huh. AI is pretty cool. Sometimes. Electric software. FPGA-C. High-level synthesis. If that is, wait, is that what FPGA is? Is it a silicon compiler? Wait, what? Oh, I'm learning! What the fuck? A field programmable gate array is a type of configurable integrated circuit. What's the integrated circuit? You need to know. An IC, also the memory chip, split chip, electronic components, transistors, blah blah blah. Cool. Oh, so this is like a Arduino? Is this an Arduino? This would be an Arduino, because it's programmed after manufacturing, right? And it has a bunch of female, like ports. That doesn't make sense at all. That's talking about cables. I'm dumb. They consist of a grid connected array of logic blocks that can be configured in the field to interconnect with other logic blocks to perform various digital functions. FPGAs are also often used in limited low-quality production to custom-made products, and research and development with higher costs of individual FPGAs is not as important where creating and manufacturing a custom circuit would not be feasible. Other applications for FPGAs include the telecommunications, automotive, aerospace, and industrial sectors, which benefit from the flexibility, high signal processing speed, and parallel processing abilities. When I read out loud, I don't understand any of this stuff I'm reading. Oh, PhD. 6 years ago, wait. No. V8, wait, Verilog. There we go. Fuck me. Wait, no, Verilog, and there's also VLSI. No, that's just a different term. Yeah, that's just a different term. Yeah, open this new window, there you go. Can I dark mode, please? No? Okay. Oh! Is this how they do it? Like on the die, so like, you know, Blackwell chips, they have the two sections, or no, let's do AMD. AM for 3D chips with a bunch of 3D cache in them, 3D cache. They split the 3D cache up to do something. Is this related to VLSI? I think it might be. Can't I just ask an AI? I don't know. I keep my thoughts organic. I can't do that to myself. I can't do that. That would be no bueno. Is my live aiming working actually? I think it is. Yes, it is. I got 0 viewers. That's perfect. Let me open chat mac and cheese here. Why does Blackwell is it's badly worded. Is VLSI related to how NVIDIA designed their Blackwell, what do you call it? SoC? Say chips. Blackwell chips. Blackwell dies. Dies? No, it's like this. It's not that. Oh, fuck it up. Okay. Chips dies. Etc. Which means even the nail say. Into split pieces. I don't know exactly what I'm asking. Oh, okay, I'm dumb. Multi-die. Okay. Oh no, it is die. God damn it. Designing each individual chiplet. Beyond Moore's Law scaling. NVLink. That's funny. Wait, the other side is just making chips. What? Okay. Wait, is the other side just making chips? We need to be contemporary here. That's basically right. It's not exactly. Fuck. No, it was such a badly awkward worded question, but it's fine. Oh, it's actually signals. Let's see. They cut the whole syllabus. What the fuck? Okay, then view our labor statistics. Alright. Isn't it kind of crazy you can just do this? Like, AI is kind of crazy. Okay. That's cool. Oh my god. Capstone Labs. Okay. That was very informative. And my hour is now up. So